Hello everyone. Welcome to the presentation of my course project work. My name is Shariyu Sabani. My project for image processing and computer vision course EEL 6512 at University of Florida Gainesville is automated pet face recognition and annotation for photo album management in gallery. Let us take a look at why is this project important and the reason for choosing this project. Firstly, face recognition systems are becoming very popular these days. Hence, learning how to carry on face recognition for humans and dogs becomes a very interesting topic. Secondly, the digital photographs is trending. Physical photographs have been replaced by digital photos, and hence number of photos are getting accumulated very quickly, and hence organizing digital photographs is desirable. Lastly, in every Apple phone and Android phone, gallery management is an available feature, but it does not group together dog or pet pictures together. And that is why I was keen on choosing this topic. Moving forward to the problem statement of the project. As the title states, there are mainly three goals that needs to be achieved. First one, to recognize dog from the input image and detect the dog breed. Secondly, group the similar dog images together. Third, annotate the picture or annotate the album. That can be done manually or automatically. The framework of the project is outlined here in the form of flowchart. As you can see, the first input and input image or number of images. We design I have designed the system such that it will take the input image and detect the image by face recognition. If the image is dog image, it will then detect the dog breed. If the image is a is detected to be a human image, it will further detect the resembling dog breed for the human face. This output is then fed to a program which will group together the similar dog images. There are many ways that we can approach this project. I have chosen to go by convolutional neural network for face recognition and dog breed detection or classification. I have designed algorithm which has basic 6 steps. First one is to import data set. We need larger sets of data to train and run the model. We download these data sets. We need two different data sets. One is dog images, another is human images. These data sets are pre-trained data sets. Let us store them at a location of our project. I am using to program Python as my coding language to program for this project. We look at each stage of algorithm one by one. Next stage is detecting humans. For detecting human face from input image, we use OpenCV implementation. I am using HAR cascade feature based classification of OpenCV to carry on the detection. HAR cascade uses feature extractions such as edge feature, line feature, and four rectangular feature to detect faces and the first to detect faces of an image, first we need to convert the image into a grayscale image. Figure 1 shows the HAR feature extraction. Figure 2 is the output obtained after the first step. Here the number of human images are detected equals to 1 because the input image is given as a human image. I have given an input image to be a dog image for the face detector, and this is why the result is printed as number of human face detected equals to 0. I have also tested the performance of this face detector. I detected 99 human faces correctly and 18 images were wrongly classified as human faces from the dog image set data set. Next step is to detect dogs. I am using pre-trained model to detect dogs. This pre-trained model is VGG16. VGG16 returns the prediction for dog that is contained in the image. VGG16 is a very deep convolutional network for large-scale image recognition. I have tested the performance as well. The correctly detected dog faces are 99 and none were classified as human faces. I have total 13233 human images and there are 8351 total dog images. Now, moving forward, we take a look at designing CNN model to classify dog breed. What is CNN neural network? Consider that a simple filter is applied multiple times to the input, which will generate a mapped feature of the input. The diagram on the right shows the visualization of this concept. In this project, I have carried on an experiment as well. We can compare the performance of CNN model designed from scratch with the CNN model designed using transfer learning. CNN model, which is designed from scratch, has three convolutional layers, each layer with a kernel size of 3 and stride equals to 1. The image which is input to the model is of size 244 by 244. We use ReLU activation function in the model and there are pooling layers which reduce the input size by 2. There are two convolutional layer at the bottom which are fully completely connected. They give 133 dimensional output. The test accuracy obtained was 14% with test loss of 3.845892 after running the model for 15 epochs. Next step is to design CNN model with transfer learning. Here I am using a ResNet 101 model of transfer learning which has 101 layers of convolution. This is a pre-trained architecture. These completely connected layers give 131 dimensional output with just 5 epochs. The accuracy obtained here is 81%. This is a significant improvement over the CNN model designed from scratch. It has taken less time to execute. We can increase the accuracy by increasing the number of epochs. Here we finish the convolutional network. After this, I have designed an algorithm using this saved transfer saved retrained models from both the network and detect the breed of the image. We can see the outputs here. This is the output of CNN model, which is designed by using transfer function. We can see that the accuracy obtained is 81%. The first image here is a dog image, which was given as an input, which pops up as an output with a message saying that hello dog, predicted breed is pointer. The second image on the right shows that it's a human face in the image. Hence, the output that we get at this point is hello human, predicted breed is American Foxhound. The next step to the project is to group similar pictures together. I have created a new Python file which needs to be executed after we are done with our main.py file. This file is compare.py file. It uses the pre-trained and saved model from code that is model underscore scratch dot pt and model underscore transfer dot pt to detect the dog breed of the input image and it groups them together. This helps us reduce the time execution of main.py file. We don't need to compile the main.py file again and again if we want to put a different input if we want to put a different set of input images. We input the images We input the images that need to be detected and managed at the static file location in the project. Once we are done compiling this file, we we now compile another file, that is ui.py file. This file creates interface which contains or shows the grouped images together. We can manually annotate the images from this user interface. There is still a very large scope for implementation of grouping of pictures together using feature extractions of dog. Let us take a look at how the code works. This is the code that I have designed on Python language using application called as PyCharm. So this window here shows the code. This is the first part, detecting humans, followed by rest of the parts that contain convolutional neural network created from scratch and a convolutional neural network created using transfer learning. This is the window where we get output after executing or compiling our main.py file. These are the epochs that we are using. At every epoch, you can see the validation source decreases and the model is saved. Only the models where the validation loss decreases, only those models are stored. Rest of them which are not stored. This is the output image that we have got, and this is the input that we have given here. We cross one image and this is the next output that we obtain. This is the image that we gave as input, and here we get a response saying hello dog, predicted dog breed is point. If we cancel that image, we get another one. Here we can see that there is a human as well as there are dogs in this image. So here the output says that hello human, since a human face has been detected, and the dog breed here we found is American Foxhound. We close this image and we are done with our first file. We have tested by giving this here, we have tested 3 dog images and 3 human images. Next is we look at our next file, that is compare.py. Compare.py file is used for grouping pictures together. So now we compile this file. Now, after compiling compare.py, we compile ui.py file, which is for annotating and generating user interface. Here we can obtain an user interface. We can see that dog gallery is available now, and there are two groups. One has this dog images and another has this dog images. Let us try to open this file. We can see all the images that are similar are grouped together, and all the images of this dog are grouped together. Now we can annotate it from here manually by changing name. Now let us take a look at the directory of our project. This is the directory of our project. It contains IFW, that is all the human images and dog images are stored over here. This is the file where we have our static folder. Static folder contains another folder named as gallery, and there are these images of all the dogs. We have taken this as input image. This explains that we can input. Now we head back to our conclusion. So from this project, we have learned that transfer learning models performed very efficiently with very less number of epochs, that is 5, and gave 81% of accuracy. The CNN model designed from scratch has 14% accuracy with 15 epochs. Transfer learning can be used to increase the accuracy significantly. Grouping of images and annotation part can be done without wasting time. We can input many images as we wish to compare and group together. The efficiency of this project can be increased, and we can effectively manage a photo gallery. Thank you very much for your time.